Now let's have another problem. We have our problem number 4. The towers of a parabolic suspension bridge 300 meters apart are 60 meters high, and the lowest point of the cable is 20 meters above the roadway. So find the vertical distance from the roadway. Find the vertical distance from the roadway to the cable at 100 meters from the center. 100 meters from the center. Okay. So I will just draw my problem. I will just draw the problem. Okay. So 300 meters apart. So let's have a point here. Point A, point B. And take note that they are 300 meters apart. Okay. So I will just put here 300 meters apart. Next, the towers are 60 meters high. So towers 60 meters high. Okay. So they are 60 meters high. Next, the lowest point. The lowest point of the cable is 20 meters above the roadway. So if since this is parabola, we may say that there will be a sag here. Okay, but the sag is 20 meters. Okay. Okay. Take note that the sag will occur at 150 meters between them. Why? Because our sag will, of course, it is equal length, so therefore it is expected that it will occur at the half side of our bridge. Now, the question is 100 the vertical distance from roadway to the cable at 100 meters from the center. So 100 meters from the center at x, see here, 100 meters. Let's have a point xy. So if our x is equal to 100 meters, what is our y? Now, there are two dilemma. So if I would consider my parabola at a vertex 0, 0, let's say, not a vertex at 0, 20, let's say the vertex is here. So considering this as my 0, 0, okay, vertex. Because there is another consideration such as my vertex is at my 0, 20, right? But now, let's consider my vertex at 0, 0. If I would consider this as 0, 0, therefore, I would create a line here. Of course, that is not my A. This is just my x-axis. Considering the vertex at my 0, 0 and my y-axis. Okay. So from that, the next thing to do is, of course, right? This is 20 meters above the ground, so therefore we would consider this length only. So therefore, this will be 60 minus 20, which is equal to 40 meters, considering vertex at 0, 0. Okay, now from this we'll have 40, 40. Okay, 40, 40. Now after considering our 40, 40, next is to go back to our question. What would be the value of our y? Take note that since we have considered this my vertex at my 0, 0, therefore this is only my y. Okay, another color. This is only my y. And the total distance of my y to the road is y plus 20. So therefore, distance, find the vertical distance from roadway. So vertical distance from roadway is equal to y plus 20. Now, let's find for the value of y. Notice that we have 20 meters here. Take note that this is not our A. Okay, that is not yet our A because our A is unknown. We did not yet assume that our 20 is A. So therefore, let's have a point A here. So we have a point A, positive A. Of course, we will consider this as 0A. Okay, y from 0 at x-axis to a value A. This is my focus. Okay, next is for my directrix. So a value 0 here, so therefore I will have a directrix at a point that is within the axis is 0 minus A because they have equal, right? So from here, if I would create my directrix, okay, so take note that if I would create my directrix, I will not consider the roadway as my directrix. Okay, so I will create my directrix, and at a point I will go back to my equation. Okay, wherein this is equal to the perpendicular distance, or it is equal, our distance from our focus is equal to this distance. Okay, now our x is equal to 100. Our x is equal to 100. Our x is equal to 100, and our y is unknown. Okay, basically if you would get that there, we will have a wrong answer. Okay, that's why the safest way is to get our A to the given. So therefore I may say that I can get my A here to this 150, 40, which is the point connecting here. Okay, 150 from the middle to my x value, this is 150, right? And a point 60 minus 20, which is equal to 40. Let's say this will be my P2. So this is the safest because this is already given. So by finding for A, solving for A, so I will consider this distance, okay, from my focus to this point, and from this point P2 to my, okay, what color should be the best here? Blue. So my P2 to this point. Take note that this is perpendicular to my directrix. Now let's tabulate the points of my directrix. So my directrix will have 0, negative a, and this point. So take note that the my directrix will have an equation equal to y equals negative a. Okay, y is equal to negative a, so y plus a is equal to 0. So I will have an equation equal to 150 negative a point here. Okay, note this is my point in directrix. Okay, now let's have our first line. Wherein this line, we'll call this FP2. So for this, take note that my FP2 is equal to my DP2, directrix to my point 2 and focus to my point 2 are equal. So my focus to my point 2 is simply equal to focus to my point 2 simply equal to, here we have 150, okay, minus 0 square plus 40 minus a squared. Okay, by further simplification simplifying the problem, the equation, I will have 150 square plus 40 minus a square. Next is my dp2. So dp2 is simply equal to square root of 150 minus 150 square plus we have dp2, we have 40 minus negative a, and this is squared. By further manipulation of this equation, this will be equal to 0 plus 40 plus a squared. Okay, since fp2 is equal to dp2, so we'll have square root of 40 plus a squared is equal to square root of 150 square plus 40 minus a square. We'll have 40 square plus 40, we have 80a plus a square. Take note that if I would square both sides, my square root will be square will be equal to 1, right? So the square root will be removed. So we have 40 square plus 80a plus a square, which is equal to 150 square plus 40 square minus 80a plus a square. Notice that our a square will be removed because a square minus a square is 0. Also my 40 square minus 40 square is 0. So I will just transpose this 80a to this other side. So 80a plus 80a is equal to 150 square. So we'll have 160a which is equal to 150 square. So from here, for solving for a, I will have a is equal to 150 square divided by 160. So we'll have a value equal to 140.625. Okay, that is our a. Now So in this consideration, I have considered my vertex at 0, 0 using vertex at 0, 0. Our equation, take note that this is opening upward. So therefore, we have x squared is equal to 4a multiplied by our y. Now, here I will have x squared is equal to 4 multiplied by 140.625 multiplied by y. I will have x squared which is equal to, so multiplied by 4, 562.5 or 1125 over 2 multiplied by my y. Now, solving for my y, solving for y, solving for y at x is equal to 100. So the next thing to do is to solve this point. Since I have my x and my y, so I will have a value of this y. So I will have x squared. So x squared is equal to 1125 over 2y. So I will have 100 squared. I will substitute my x here, which is equal to 1125 over 2y. We can solve for our y, which is equal to, shift store at a. So shift store at a. So I will use my calculator here so that you can see this. Okay. Okay. So we'll have 100 square all over 100 square all over 1125 over 2. So 1125 over 2. We have a value of our y which is equal to 17.77 meters. Okay, this is not yet the answer. Okay, basing it on my diagram a while ago, our vertical distance, or I will call this as my VD from our way to y is equal to y plus 20, in which I will have 17.77 plus 20 or 37.77 meters. Okay, that is my answer. Now, you can also direct substitute the values of x and y if you already have your a, to find for your a. How? Okay, that would be our solution 2. Solution 2. Take note that we have x squared is equal to 4ay. We have found for we use the p2 for our xy. So using p2 as our 150 and 40 as our x and y, so we'll have a value equal to, finding for a we'll have x squared which is equal to 150 square which is equal to 4 multiplied by my a multiplied by my y which is equal to 40. So take note that I use my x and y in this example. So therefore my a will be equal to 150 square all over 4 multiplied by 40. So we have my a which is equal to 140.625. Since we have similar a, the next steps will be similar. Okay, you will just again substitute a to our equation, and then next you would substitute our x which is equal to 100 to this equation to find for our y, and then y plus 20. Now we have our third solution. If you would not want to use my plus 20, is that we'll use the equation of x minus h square, which is equal to 4a multiplied by y minus k. Okay, so from here our h and k are vertex, wherein from here we may use our vertex 0, 20. So we have 0, 20. So from here you will have x minus 0 square, which is equal to 4a multiplied by y minus 20. Okay, wherein our a is also equal to 140.625. Okay, so from here we'll have a value equal to x square, which is equal to 4 multiplied by 140.625, 140.625 multiplied by y minus 20. So at vertex 0, 20, so we'll have x square, which is equal to 4 multiplied by 140.625. So we'll have 562.5 multiplied by y minus 20. Now, considering our x is equal to 100, find for y, we have 100 square, which is equal to 562.5 multiplied by y minus 20. I will have 100 square divided by 562.5. So we'll have 17.77, which is equal to y minus 20. So y is equal to 17.77. So I will transpose this. This is also equal to 37.77. Okay, they are similar. Note, in my first equation and my solution 1 and solution 2, I use the vertex at 0, 0. And for my solution 3, I use the vertex at 0, 20. Okay? Now, if you already use your vertex at 0, 20, there's no need to subtract 20 to your 60 meters. Okay? Because you are free to use that. Take note that our 20 meters will not be our A. Okay? We must find for our A in order to solve for this problem. So in every parabolic problem, the key is to find for our A, and also to know the different parts and where the vertex of our parabola is.